Good afternoon and welcome to the Q&A session 15 from the chapter of moving charges and magnetism. The topic is the calculation of resultant magnetic field, and based on this topic I have one question for this session which was asked in the IIT JEE main exam in the year 2025. So ये इसी साल का question है. The question here is a current carrying square loop of side A is lying in a plane as shown in this figure. The resistance of the part ABC is R and the resistance of the part ADC is 2R. So the resultant magnetic field at the center of the square is. तो यहाँ चार ऑप्शन दिए गए हैं and we have to find the correct option. So in order to solve this question, we have to follow certain steps. First step तो यहाँ पर ये होगा कि first of all I have to find the current in the part ABC and in the part ADC. Then I will find the magnitude of the magnetic field due to each part, that is AB, BC, AD and DC. Then we have to find the direction of the magnetic field due to each part. If the magnetic field is directed into the plane, then it will be taken as negative, and if the magnetic field is directed out of the plane or outward, then it will be taken as positive. तो पहला पार्ट हमें करंट निकालना है. इसका ABC का पार्ट का जो रेजिस्टेंस है वो R है, and the resistance of the part ADC is 2R. So the current in the part ABC, say IABC. So the ratio of the current in the part ABC to the current in the part ADC, this will be equal to the resistance of the part ADC divided by the resistance of the part ABC, and this is equal to 2R by R. So this is equal to 2. So the current in the part ABC is 2 times the current in the part ADC. So we can say that the current in the part ABC, this will be equal to 2 upon 3I because the total current is I. And the current in the part ADC, this will be equal to 1 upon 3I. So first step, we have completed the first step of finding the current in each part. Second step is we have to find the magnetic field due to the individual branches at the center of this square loop, that is O. So let us first of all find the magnitude of the magnetic field due to the part AB. So BAB, this will be equal to mu naught I. Now the current in AB is equal to 2 upon 3I. So I will be substituting the value of I by 2 upon 3I divided by 4 pi R. R is what? R is the distance of this point from this current carrying this current carrying conductor. So here the current in this conductor is equal to 2I upon 3, that is in the part AB, and similarly the current in the part BC will also be equal to 2I upon 3. Now the distance of this point O, which is the center of this square, from the this current carrying conductor is equal to A by 2 because the length of each side is A. So this distance, that is from O to this wire AB, this will be equal to A by 2. Similarly from this point, let us say this point is ABCDO, let us say this point is P. So the length of PB will also be equal to A by 2 because this is the midpoint of AB. So if this is A by 2 and this is A by 2, then this angle will be equal to 45 and this angle will also be equal to 45 because tan theta is equal to perpendicular upon base. So this will be equal, tan theta will be equal to 1. So theta will be equal to 45 degree. So here the formula is mu naught I upon 4 pi R. Now here R is what? It is the distance from this point from this current carrying conductor, which is equal to A by 2. And in bracket sin phi 1 plus phi 2. This is phi 1 and this is phi 2. So sin phi 1 will be equal to 1 by root 2 and sin phi 2 will be equal to 1 by root 2. So this will be equal to 2 upon root 2. So this is equal to, this will get cancelled out and I will be getting mu naught into 2I divided by 6 pi a. This is mu naught I into 2, and this 3 will come in the in the denominator. So this is equal to 6 pi a, and this is equal to 2 upon root 2, and 2 upon root 2 can be written as root 2. So this is equal to root 2 mu naught I divided by 3 pi a. So this is the value of the the magnitude of the magnetic field due to the part AB. Similarly, the magnitude of the magnetic field due to the part BC will also remain the same, but now we have to find the direction of the magnetic field due to this part AB and BC. Now here I will be using the right hand thumb rule. The thumb will point in the direction of the current, and the curled fingers, my curled fingers, will point in the direction of the magnetic field. Now it is pointing, the curled fingers are pointing into the plane. They are pointing inwards. So the magnetic field will be directed into the plane. So this magnetic field due to these two parts, that is AB and BC, will be accompanied by a minus sign. Now let's find the magnetic field due to the part AD and DC. So AD, this will be equal to mu naught I. Now I in this part is equal to I by 3. Mu naught I upon 4 pi r. R is equal to A by 2. Again sine phi plus sine here this sine phi 1 and phi 2. So this will be equal to sine phi 1 is equal to 1 by root 2. That is 1 by root 2. And again sine phi 2 will be equal to 1 by root 2. So this is equal to 2 root 2. So I can simply write this as 2 root 2. Or simply this can be further be written as root 2. So from here, this will be equal to mu naught I root 2, mu naught I root 2, and this will be equal to 6 pi a. Now the magnetic field due to this part AD will be directed out of the plane, because the direction of the current here is opposite. So the magnetic field due to this part AD and due to the part DC will be taken as positive. So here the magnetic field due to the part AD will be equal to the magnetic field due to the part DC, and its value will be taken as positive because the direction of the magnetic field is out of the plane. Now we have to simply find the resultant magnetic field. So in order to find the resultant magnetic field, I will first of all here write down the value of the magnetic field due to the part AB, which is equal to minus root 2 mu I upon 3 pi a, and the magnetic field due to the part DC, this is equal to root 2 mu I upon 6 pi a. Though the resultant magnetic field, this will be equal to the magnetic field due to the part AB, which is equal to minus root 2 mu I upon 3 pi a. The magnetic field due to the part BC, again this will be equal to the same value, so I will be just multiplying it. So this will be equal to or we can simply write it as minus root 2 mu I divided by 3 pi a, and the magnetic field due to the part DC, this is plus 2, plus होगा because in this case the magnetic field is directed out of the plane, so it will be root 2 mu naught I divided by 6 pi a, and due to the this magnetic field due to the part DI, this will be also equal to root 2 mu naught I upon 6 pi a. Now we have to simply solve this. So from here, this can be further written as this is equal to 2 times, so this is equal to minus 2 root 2 mu naught I divided by 3 pi a, and plus 2 root 2 mu naught I upon 6 pi a. So this will be equal to, if I take the LCM, this will be equal to 6 pi a, and this will be equal to minus 4 root 2 mu naught I, and this will be equal to plus 2 root 2 mu naught I. So this will be equal to minus 2 root 2 mu naught I upon 6 pi a, and this can be further written as minus minus root 2 mu naught I divided by 3 pi a. So this is the magnitude. The magnitude is equal to root 2 mu naught I upon 3 pi a. So this is the answer. That is root 2 mu naught I upon 3 pi a. The minus sign is indicating that the resultant magnetic field is directed into the plane. The magnitude is equal to root 2 mu naught I divided by 3 pi a. So the correct option here is B. So thank you very much for joining this session. In the next session, I will be coming up with a different type of a question. The chapter will remain the same, that is the moving charges and magnetism, but the topic will be different from what we have taken in the in this session. So till then, have a nice day. Bye.